Okay, for this part, I'm going to show how to do the association rule mining in Weka. I've opened up the German credit card data set. It has a lot of features, and it's just one that's kind of ripe for association rule mining because businesses want to know if employment is correlated with a good credit history. They want to know if that's an interesting rule or not. So first thing, there's some numeric features. So I chose the numeric to nominal filter, and I'm just going to accept the defaults because this is just a demo thing. So now I have all nominal features. I can go to the Associate tab. And if I want to use confidence, we saw before that that was the default metric type. If we look at the other ones, though, there's lift, leverage, this thing called conviction is the last one. All of these are commonly used. They're related, but different measures. I'm being merciful. We're not talking about conviction. But if we use lift, remember that we want to use a metric that's going to be bigger than 1. So a lift of 1 is statistical independence. That means it's not a good rule. So our metric needs to be bigger than 1 for lift. And so when I do that, I get some rules that it returns. And we can see what the lift is. These are above the threshold, just barely. So these rules, these are the ones in the data set that it found that have the biggest lift. So I either lucked out or was wise in choosing my threshold. And it was luck, I just guessed this. But these are the ones above the threshold. So these rules are all by definition interesting. The problem with using confidence as the metric is we would not know if we actually found good rules or not. We would have to do further correlation analysis. But if we use the lift as a metric, we don't have to do that further analysis. We can be sure that we got good rules. If I want to consider a different metric, the leverage, then all I have to do is change this and then also change the value of my threshold. So with lift, 1 means statistical independence. With leverage, it's 0 that means statistical independence. We want positive correlations, so I pick a threshold that's positive. It's above 0, but it doesn't have to be above 1 in this case. So I'm going to pick 1/2, try the same thing over, and I don't get any rules in this case. So what we see is that my threshold was actually too high. And there's no guarantee that the statistics are going to work out right, so that a lift of 1.5 gives you a leverage of 0.5. I was hoping it would, but it didn't. So another set, I'm going to lower my threshold to 0.15 for the leverage. And now I'm going to mine the rules. Okay, and I didn't have any luck there still. So what I'm going to do is I'm going to keep considering different thresholds. I'm going to lower it to 0.05. And then I'm going to check that. And so now I actually have some rules. And so when I look at the output, here's my leverage. It's 0.14. So my threshold of 0.15 was just a little bit too high. If we compare the lifts that we got, and what we see, these lifts are about 1.4. And so I didn't see these rules before. What this illustrates is that lift and leverage aren't simply related. The best rules I had with lift are showing up here, but not all of the good lift rules. So life's a little bit more complicated where we can't just pick one parameter. What we can say is that lift and leverage are both more useful than just using the confidence. And so a good way to mine these would be to use both of them and then see which rules we have in common between the two, but then also see which rules appear in one set but not the other. And then depending on our business needs or our interest with the data mining, we can decide which ones are the most important.